that.
Whoa. That's a big
Hey, we
jump.
passed 7th grade.
Hey!
Instant pass.
Yes!
Instant kill.
This still isn't the quadratic form.
You say it's
It's identifying quadratic functions.
This is part of getting to the quadratic formula.
Wait, this is easy.
Grand boy.
You underestimate my power.
Oh, poor Wade.
No, it'll be fine.
Alright. Basic gist of what today is talking about is this. When you talk about a quadratic or a quadratic function, really what should come to your mind is simply x squared. A quadratic function has an x squared in it. The x squared is the highest degree term you can have in a quadratic. Okay? Now, which means this. Anything that has that x squared in it, it could be this. X squared plus 2x minus 3. That is a quadratic. Usually when we think of quadratics, we say that equals either the function of x or y. It really doesn't matter. It's all the whole same sort of thing. It's a little like this. All right, linear equations we're always in this form, y equals mx plus b. That's a linear equation. Linear because it's just a single x. Quadratic because it has an x squared. If it had an x cubed in it, we'd call it a cubic thing or whatever. Remember we did it? Didn't we do an IXL thing? We did an IXL thing on this. Now, you need to recognize what does a quadratic look like? Well, when you graph it, it's a parabola. But before we get to that, we should write down the generic quadratic. Quadratic looks like this. You know, like y equals mx plus b. This is ax squared, f of x, equals ax squared plus b times x plus c. A, B, C. But remember, these don't have to be there. You can have zeros for these numbers, and if you had zeros for these numbers, you wouldn't have anything but an x squared. But it's still a quadratic because you can put it in there at 0 things there. This, I guess they call this the standard form. This is your standard form of your quadratic. Standard form. And if you graph a quadratic, I suppose we should do that somewhere. Let's just say this. If you have f of x equals x squared plus, I don't know, what, 2x minus 2. We could spend all day doing this, but we'll do just one so you can see it. We will actually pick our x. I guess this would be f of x. It doesn't really matter. Let's do a couple. If I put 0 in for x, which is nice because that gives you 0, that gives you 0. What does y equal? 0 plus 0 minus 2.
-2.
Oh,
That
was
was a
supposed
little
to be
tough.
a Z.
Huh?
I thought that was a Z.
No, it's a 2. Z's have little slashes through them. What if x is 1? 1 times 1 is 1, plus 2 times 1 is 2, minus 2,
0.
you get 1.
Oh.
What if x is negative 1? Negative 1 times negative 1 is a positive 1. Negative 2, negative 2, no. Negative 2 is negative 4, plus 1 is negative 3. What if x, let's just do one more. If x is 2, 2 times 2 is 4, 2 times 2 is 4, 4 plus 4 minus 2 is?
6.
Wow, you guys are fast. What if x is negative 2? Negative 2 times negative 2 is positive 4. This becomes minus 4 because 2 times negative 2 minus 2. You get 4 minus 4 minus 2. 4 minus, thank you, negative 2. Okay. Now, let's look at what the graph of this looks like. What is the graph of a quadratic? Well, here we go. 0, negative 2. 1, 1. 1, 1. Negative 1, 3. Negative 1, 1, 2, 3. Wait, sorry, negative 1, negative 3, wasn't it? No, wait. Did I do that right?
-1, -3. No.
Negative 1, 1.
You did 3. It's -3.
-1, -3. We have to get rid of this one here. That one's not there. What's 2, 6? Something's not right here. 2, 1, 6. Something's wrong here. -2, -2. Oh, no, that's right, I'm sorry. Let me get rid of this one, because this one's making me think. These pretzels are making me thirsty. This is not here. Alright, so if you look at those lines, first thing you notice about the lines is they are not linear. You do not get a straight line. What you do get is this shape. Here's the bottom of it. It goes up like this, and it goes up like this. The shape of a quadratic is what we call a parabola. So anytime you see a parabola, you should think about a quadratic. And there are some definitions of these parabolas that you need to know. Well, maybe they don't give them to you now. Maybe I won't give them to you. Or an inverted catenary curve, which this isn't. All right. If it's a positive x squared, it's this shape. If I would have switched this around and made this negative x squared, negative ones, negative x squareds are upside down U's, sad faces. Got that? Positive x squared is a U. Negative x squared is an umbrella-shaped looking thing. And I think that's all they actually give you for right now. We do talk a little later about this. But that's not, we don't want to do, let me see what they ask you to do. Look at, I don't know. Look at, no. Sure, why not? Look at page 553. In your books, look at page 553. Well, maybe we will. Maybe I will give you this. Write this down too. This kid is so smart here. If you look at a parabola is symmetric. Symmetric means what, Carter Westfall? What is a symmetrical shape? Anybody out there? Why are you guys so close to me? Jacob, let's put some. We talked about lines of symmetry before. What does symmetric mean?
You can cut a shape in half and have two of them looking the same.
Yeah, they're mirror images. Like we're basically, as human beings, we're symmetrical. If you draw cut us right in half like this, one side looks like the other. This parabola has all parabolas have what we call a line of symmetry, and that would be that. I think I need. But we don't call it a line of symmetry, we call it an axis of symmetry. And this would be right here. This little thing right here goes right down the middle. That little pink thing is called the axis of symmetry. And then you have this thing right here, where the thing bottoms out. Any idea what that's called? It's called the, well, first of all,
Bottom of it.
this is called the vertex. But it's also called, this one is the minimum. Because that's as low as it goes right there. It has a minimum point. And then if it happens to be a negative one and it looks like this, since this is as high as it gets, if it's negative one, it's not a minimum, it is a maximum. If it's as low as it gets, it's a minimum. If it's as high as it gets, it's a maximum. Those things right there, I mean, I don't think there's anything else that's, well, there is, but we don't get to that. Wait, how close are we to the quadratic formula. Where is the quadratic formula?
Or there's identifying characteristics of
Oh, there it
quadratic.
is. Maximum, minimum, vertex. Oh yeah, there's another one.
Wait, where is the?
This is way back lesson, but we'll put it here. And the place where it crosses the x-axis, here and here, those are called the zeros of the quadratic. Why do you suppose they're called zeros there?
Because it's 0 on the y-axis.
Because it's where y is 0. If you put 0 in for y, you can figure out what that is there.
What makes the parabola go on its side?
You mean like this?
Yes.
I don't think it does.
I thought it.
If it did, it would not, first of all, be a function. You can't have that. It will not go on its side like that. Not for us, not for yet. That's a higher level math that we will not get there.
Not for yet.
Not for yet. All right, perfect. We shall stop there because this one is just about defining it. We eventually do get